everyone. Welcome. Today we are going to discuss some basic mathematics that are very important for your study in digital signal processing. So pay attention with me as we go through those mathematical concepts. So these concepts are going to be very helpful if you want to understand digital signal processing very easily. So we start with sine and cosine, those two mathematical concepts of trigonometry. There are certain common angles that you need to be familiar with. If you don't want to memorize, at least you need to be familiar with. So what are those common angles? So we have on the left side the angle 0 degree, 45 degree, 90 degree, 180 degree, 270 degree, and 360 degree. Those are common angles. So you need to be familiar with the sine and the cosine of those angles. For example, sine of 0 on the first row is 0. Cosine of 0 is 1. On the second row, sine of 45 is 0.707. Cosine of 45 is also 0.707, and then you continue like that. On the third row, for example, sine of 90 degrees 1, while cosine of 90 degrees is 0. So you need to be familiar with this table, common angles and sine and cosine of those angles. So you also need to remember that cosine function is an even function. So if you wanted to compute the negative of the angle is the same as the positive of the angle. So cosine of 0 is equal to cosine of negative 0. While the sine is an odd function, which the opposite holds. So sine is an odd function. So if you flip the sign of the angle from positive to negative, the value also flips. So sine of theta is minus of sine of minus theta. And in terms of pi, you need also to know the angles in terms of numbers and in terms of pi. So 190 degrees is a pi. Pi divided by 2 is 90 degrees. 2 times pi or 2 pi is 360 degrees. You need to answer what is 3 pi. So the basis is pi 180. So you need to multiply 3 times 180, and then you need to get the answer. So in terms of also, you need to be able to interchange between the angle in number form and the angle in pi form. Next, we need to also understand the complex number. The complex number is written in this way: z is equal to x plus jy. In mathematics, I is used, but in digital signal processing and telecommunications, we use j when we are talking about electrical terms. So z is x, which is the real component, plus the imaginary component. So when you are given a complex number in this form, you should be able to write in another form called magnitude angle form, or what you call amplitude phase form, sometimes they call it. So let's do that. So x is the real part and y is the imaginary part. If you want to find the magnitude of that complex number, it's written as in this way. You need to put a double bar and then insert the symbol z there, and you need to be using this formula. The square root of the real part is square plus the imaginary part is square. Of course, j is going to disappear in this formula because j square is equal to 1. So if that's the amplitude or the magnitude, how can we write the angle or the phase of the complex number? It's given by the inverse of the tangent imaginary part divided by the real part. So if we have a complex number in this form, in amplitude phase form, amplitude is given by this formula, where the phase is given by that formula. So let's take an example. So write the following complex numbers in magnitude angle form. Z3 minus J. So the amplitude is given by the number, while the phase is the inverse of the tangent. I hope you understood. Another thing in digital signal processing, mathematical concept is exponential to trigonometric. So if we have an exponential number, we can convert it into trigonometric and vice versa using Euler identity. So in terms of positive, exponential e power j theta, that's exponential complex number. It can be converted to exponential trigonometric number, which is cos of theta plus j sine of theta. In terms of negative, you can also get, because we say that the sine is an odd function. If you change the sign of the angle minus theta, you will get minus here, but the cosine will not change. I apologize that there is theta missing after cos. I'm sorry for the typing error. So let's take an example. If we have e power j pi, we know that pi is 180 degrees. It can be converted into using the Euler identity on the top. Cos of pi plus j sine of pi. What's cos of pi? We learned it in the first table. Cos of pi is -1. Sine of pi is 0. You need to go back to the table of the common angles of sine and cosine. So if you add, you will get -1. So e power j pi is -1. E power j minus j pi over 2 is minus j. So you need to use the sine and the cosine of the common angles we discussed in the previous table. I hope now you understood the Euler identity, how to use it to convert or interconvert between exponential and trigonometry. The last one I want to mention is summation notation. You will see this mathematical concept a lot in the digital signal processing. So in mathematics, if you want to add those 5 numbers, 1 plus 2 plus 3 plus 4 plus 5, you will get 15. So we can count this one because the list has a beginning, which is 1, and an ending, which is 5. So there are 5 numbers. We can denote as a k. So k will start from 1 to 5. If you add, you will get 15. So we can also write in what we call sigma notation or summation notation. So this is the way we use. We use this big Z, which is summation. So on the lower part, we place the starting point. So k starts from 1. On top, we place the last number or the last digit, which is 5, and we place here k. So we start with k is equal to 1, 1. Then summation we add k is equal to 2 plus 3 plus 3 plus 4 plus 1. So that's the way you are going to be using summation notation. So you can also take this example. If you are given to evaluate 2k plus 2 from k0 to k3, this is the way you are going to be writing, which means in summation notation k starts from 0 up to 3, and this is the expression. So you expand and you will get what you want. So I hope you benefited from this video of common mathematical concepts you need in digital signal processing. Please subscribe. We will upload more. Thank you.